Hey everybody, welcome back. Joe Costello with the Professor, Warren Johnson, Jaden McCurry. This is like the Professor. Jaden is just 21 years old. It's kind of interesting how he fell into this career. Was just telling me a little bit about his life. He loves cars, and now we're on set with Warren Johnson. Warren, these machines, you told us a little bit before, it has just totally changed the way with which you can efficiently produce, try ideas, and do things. And we look at a guy like this, 21 years old, he's already working on the machine. We're going to work on some stuff here. Maybe you see a little bit of yourself in some of these young folks.
Oh yeah, well, they've got the luxury of these machines where I didn't have that before, but I appreciate what these machines can do. But the biggest thing is you have to look at the ability of the software to achieve what you want to achieve. When I design a port now, all I do is put the head bolts in it, put the valve seat in it, the valve guide, push rod holes, and I put a port in there, all on the computer.
And Jaden,
don't hand port it.
And Jaden, you guys were talking already. They were discussing like speeds and bit speeds and like different things about keeping the surface as clean as is possible. Talk a little bit about that and how that information is obviously constantly updated.
Yeah, I mean, for any material that you're going to cut, you know, every different head's going to have a little bit of a different, I guess, attribute to it. They all going to look a little different in your surface finish. And for somebody like him to be able to just walk up and know immediately off the top of his head that something can change, it's pretty amazing.
What about that, Warren? You know, when you see you're running a program and is there only one way, or are there a multitude of ways depending on what you're working on?
There's so many varieties of materials, as he was alluding to. You got different alloys of aluminum, you got cast iron heads, that changes, cutter configuration, and what you're trying to achieve. I looked at that and I thought, oh, this is way too slow for me. I gotta get this thing up about 100 inches a minute and 9,500 RPM spindle speed on it, because I'm worried about production.
Right.
And he was worried about finish, so he's got his approach to it and requirements, and so do I.
Now, you got the nickname as the Professor for many reasons, but noticing and recognizing interest in someone and the ability, right? Like, oh, this is someone who is interested in what I know and what I can do in the field I'm in, and also has the ability. We got one of those people here with Jaden. But what has that been like over your career to try to bring people along?
Well, there isn't that many technical schools available nowadays as there was in the past. There's some, but I don't think they offer the variety of courses that need to be out there. You have to realize there's going to only be so many doctors, lawyers, and Indian chiefs in this country. But the day's coming when the mechanic can charge the lawyer more than he charges per hour.
Right, and by the way, that is happening right now. Jaden, what about you? You've been trained, you use the machines, you're obviously here and you're solid, but you got an opportunity with Warren Johnson right here to download any information that you could possibly dream of. What are some of the things that you think about as you work with the machines and go through the process?
What exactly do you mean as far as what am I thinking about? Well,
if he's got something in his brain that you want to pull out, like now's the time. We've got him right where we want him, and he can't leave, at least while we're live. You know, his great career and being a pioneer for all this stuff that you're now using now on a regular basis.
It'd be really interesting to know how things got to change. You know, I'm younger in age, so I know things have adapted and updated greatly, but I haven't had the chance to get my hands dirty and see, you know, each stage as things have progressed, you know, from me jumping on this and knowing what its capabilities. I haven't really been able to be on, say, the predecessor to this, you know, 10, 15 years ago, as far as how hard it might have been to go through versus how simple things are now. It'd be really interesting to hear some stories on stuff like that.
Warren?
Well, it's kind of interesting. I bought my first CNC in 1992, 28 years ago, 29. And that was a traditional 3-axis with a 4th and 5th axis table on it. And looking at what the software could do back then as opposed to what I have available today, today's machine, from the original cylinder head that you want to duplicate to the finished product, the new machine is roughly 7 times faster than what we had before.
It's amazing.
And considering how fast you could hand port a set of cylinder heads, it's unbelievable.
Yeah.
And you were using other elements like, the sound of the machine and to determine if it was right in the zone where you wanted, like that. There was a little maybe more feel back then. Try to go into that.
A machine will talk to you, basically. If it's not comfortable with the cutting speed you have or spindle speed or whatever, it'll tell you that it's uncomfortable, and you can look at the surface finish and verify it. So you're going to have to experiment with different feeds and speeds for, as you said, different materials.
So as technology evolves, like, I think of like a rotary phone. There's no benefit to a young person going back and using a rotary phone. Is there a benefit to a young person like Jaden maybe having an experience on an older machine just to see what it was like? Or can he feel confident just storming forward with the latest Rottler equipment?
Oh, you're better off taking what everybody has put before you, what they learned, and incorporate it in the new machines. I wouldn't really go back unless you want to do it the hard way, but no, the new machines now are so much better than they used to be. That start there, because you have to realize it's going to get better yet.
Yep. And Jaden, on that note, how much time do you spend doing research into the ways maybe some of the predecessors who were doing what you do did what they did at the time, so you could learn from that information?
Not so much on older porting machines, but if you think back to more manual machines like a Bridgeport mill, lathes and stuff like that, I do a lot of, I guess, researching, because it's always interesting to see, even if you're going to make parts, how people set up, how people get through problems they may see with something on a manual machine that you have to crank by hand. You may get to something that you're completely bumfuzzled on, like a 5-axis machine. But if you have that knowledge that you've seen somebody else do something the hard way, you can always take something that you've seen that them do and apply it to whatever your situation is.
The basic process is the same. They just sped it up with machines.
Interesting. Problem solving.
Mm-hmm.
Warren, something that, Lake and I do this podcast called Hidden Horsepower, where we're speaking with engine builders. By the way, you've got to get you on there at some point. And at the end, I always ask for advice, right? So to forward advice, like, is there a piece or something significant that every young person in Jaden's situation should keep at the front of their mind as a piece of advice that will help them, kind of like a guiding focus throughout their career?
Well, basically, you have to make it to the best of your ability. You have to look at what the machine is capable of before you can say you can do this, that, or whatnot. So you have to educate yourself into the available processes that machine can go through. Because there are certain things that need to be tuned up yet that I've run across, but they're minimal, but it would help finishes, speed up development, so forth. So it's always a constant evolution. That machine will probably be obsolete in 5 years. Or at least the software will, put it that way.
Which, of course, there's always updates, and I think that those updates come from the feedback of people who are using the machine, right? Like, you run into that problem you were just talking about, like, okay, we got to a point where now we have a challenge. You solve that challenge, give a little feedback, and then they can incorporate it into the next design. I mean, isn't that how everything evolves?
Rottler's been extremely good about that as far as updates on the software and so forth. So it's going to be constant. It never stops. It's just like, as I said before, power output is just a result of how much you want to think about it and available materials, in this case, machines.
And I would love to know something. I think that so much can be learned from failure and fail forward. Like, you don't want to go through that process, but every time you do, there's something to be learned. I'm sure you've got a great story or two of something that you thought was like, this is it, man. I've got it. And it didn't work out, but you learned from that experience.
Oh, yeah. That's like I said before. I never throw anything away, because I look at it, a year, 2, 10 years later. What were you thinking at the time? But it was, at the time, I only had so much information available, so I made that decision. Had I had a little bit more information, I would probably not done that operation, but you learn. And you're going to make failures if you're doing any development work, and you have to learn from your failures. because you're going to have more failures than you're going to have successes, and that's a fact.
So Jaden, don't throw anything away. Starting now, keep it all.
I can do that.
Now, I am interested, you know, how do I say this? Jaden's generation
Got noisy ZX.
Yeah, man, it's going after it. Maybe sometimes gets a little bit of a bad rap for not wanting to be hands-on, but here this guy is 21 years old and he's already knows how to program the machine and make parts and make chips. That gives me hope. What say you, WJ?
Well, yeah, it's good to be in their position because they've got the ability to produce parts. But at what level of parts do they want to produce? You know, he's producing something that somebody else has wanted, somebody else developed. That's fine. And as long as you can produce it efficiently, so your employer comes out on the right end of the stick, then you're all right. But you always have to have the concept that you want to build the best possible piece you can. Second place is the first loser.
And on that concept, Jaden, thinking about things that you've worked on and want to work on in the future, you know, the ideas that you will have, like what gets you excited about what these things can do?
Just being able to make new things is enough to keep me happy, and because I've always had a thing for learning something new. So just even if it's a new trick or something else that I find out that I can do with this machine, it's just, I don't know, it's something enough to make me happy. So I can't ever really think of something in the future that I might just want to make or exactly where I want to go. But I've been with Straub for, I guess, a little over 2.5 years, and I've not found myself bored or I guess twiddling my thumbs at any point. I'm always excited and always find something that keeps me going.
And I would imagine that's the same with you.
Oh yeah, you have to learn something. Every day you have to learn something. I don't care how minuscule it is, but if it's something you didn't know yesterday, you've had a good day.
And that keeps you young. That's also, like, I think the day you get old is the day that you stop wanting to learn something new, because you know it all and it's all old news anyway.
Nobody knows it all, I can tell you that.
That is great. Jaden, a couple of final thoughts here. You know, get to sit with the Professor Warren, knowing what he's done. I don't know if you're a big NHRA drag racing fan or not, but you know, the guy is obviously a legend. But the on-track stuff might even be secondary to this community, the engine building community. We're expecting big things out of you, young man. We want you to go on and do something huge. What kind of racing do you like?
Drag racing. Shoot, anything that goes fast, I'll sit there and watch it. It's fine with me.
That is awesome. Now, Warren, we got some questions earlier about you and things you know, outside of drag racing and other manufacturers other than you know, General Motors, and we didn't get to wrap that one in. Someone wanted to know if you'd ever drag race anything that wasn't General Motors.
I personally haven't, but I built some, I think they were Super Soft D American Motors engines at one time. Did a lot of development work for Kickoff for Marine for their offshore boat engines. So anything that, as I say, goes putt-putt and smells bad, I'm really interested in it.
Excellent, excellent. As far as challenges, you know, you've touched on a couple of things like finding limitations, and it happens from time to time. Off the top of your head, I'm sure this is a very deep story, but what is the thing that maybe has flummoxed you the most over the years, a challenge that maybe you keep bumping into, and technology is helping us get to the point where someday you will break through?
Well, when I look at the normal internal combustion engines we're dealing with, probably valve train control really is the point that it hasn't been solved totally yet. Well, NHRA won't let me do it. I did it in 1992, and they outlawed it immediately, so that kind of set us back.
Was that in the book?
Probably not.
How did you solve it?
Built a pneumatic valve train.
The pneumatic valve train. So
we could run a conventional valve train at 94. Now you have to realize we didn't have hollow stem valves. Valve spring development at that point in time was rather crude compared to today's standards. So 9,400 RPM was about as fast as you could run them in 1992. And we ran, and a valve spring, a steel valve spring lasted 30 seconds. Titanium spring lasted maybe a minute. And pneumatic valve train, we ran at 13 to 14,000 RPM for, I think somewhere around 2 hours. It didn't even get warm.
And there you have it. He is the Professor Warren Johnson with us here at the Engine Performance Expo. Jaden, thank you very much for what you have done. And I just love seeing this, the generational connection in engine building, machining, and otherwise. For you folks out there, stick around. Warren's going to be around later on today as well. We're going to have a great time. Right now, though, we're going to throw to our next subject. Next subject is axis machining, something these two know a whole lot about, and I'm going to be very interested in the video. So stick around.
Hi, I'm Chris Straub with Straub Technologies, and I'm here with Jaden McCurry. Jaden operates our EM69 Rottler CNC center that we use for porting. At a point in Straub Technologies, we had come to a point where we needed something that could replicate the development work that we had been doing here at Straub Technologies as far as for cylinder heads. Asking a few questions of people, what CNC cell we needed to buy for CNC porting. And one company kept coming up, and that was Rottler. And one reason is because Rottler is a self-contained digitizing and machining center. Not only can we use the Rottler to do the machine work, but it can also digitize the part that we want to replicate in the machine. Straub Technologies grew from my garage. Never thought that I would be doing anything like this. I've been in the industry for 25 years, but people now with the DIY mentality, they want to be that Grumpy Jenkins. They want to be that Keith Dorton type person and build their own motor and stuff. So with the Rottler and being able to produce over and over and over again the same quality type part was important to me. So I need to provide something for my customers, and that's what the Rottler machine allows us to do. When I bought the Rottler came to me, and when in talks they said, Chris, you don't have to know speeds and feeds and all this stuff. The machine knows that. As long as you can work windows, then you can become a CNC operator as far as doing port work and stuff. Now, for myself, that's nothing that I want to do, but I was able to hire Jaden, who came out of high school, and adapted to the machine very easily. Even though Rottler uses their own exclusive software, it was something that he understood with his background. So somebody thinking about buying a 5-axis machine for porting, they don't have to worry about Rottler's software. Rottler's software is easily adapted to anyone that's had any background as far as the type of machining. So one thing that we do enjoy about the machine is the manipulation of any of the data points that Jaden is able to capture using the Renshaw probe on the cylinder head is easily seen here. And all of these lines presented captured data in the combustion chambers. Each one of these is where the probe is touched, so it's mapped out this combustion chamber of this cylinder head. And Jaden can then go into his computer system in his office, and anything that he needs to smooth or reshape is easily done. That's one advantage the Rottler has over multiple machines, is that its ability to capture data so fast. You'll hear about people that have digitized over the years, and it might take them a week to 2 weeks to do an intake port, an exhaust port, and a combustion chamber. Jaden's been able to do this in a matter of a day. So whether important to me, then I don't have to have as many people, but can produce as much parts as some other much higher volume shops. So for me, as a small business owner in the automotive performance industry, Rottler was my choice.
Yeah, so this is a port that has already been digitized, and it's already got the through section, so it has its solid surface. If I want to go through and change, say, the plane that's right here on the seat surface. If I want to shrink this entire section, I mean, it's as simple as right-clicking on the plane. You can go to section offset. If I want to offset it, say, 250 thousandths, just so you can see what it does. I mean, you can see it blew that entire plane out just that quick. So every little change that you make on this thing, you can see all the results, you know, just about as quickly as you want to do it. So you want to change the radius in the corner of this plane. Click that, you can change your arc. So you just make it a straight line or whatever. And you can see it right there immediately as you do it. So it gives a really good reputation as you go through if you want to smooth things. I mean, there's really not a lot of waiting to get things happy like you want it to. But with each plane that you go through and digitize, which is what all these sections are with the data points, it keeps record of the sizes, so it's got its own little graph as, I guess, like a little representation you can keep track of, but you can check out your cross-sectional areas. So you pull the list up, so this right here is the manifold section, so it's the first section on the manifold side for the intake port. It gives you your true section area, digitized section area, you've got average true diameters, program diameters. It gives you the distance between the planes. It'll tell you how far you are from this manifold plane. So I'm starting right here at the manifold section. So right there it says distance to the next plane. You got 261 thousandths. If I go to the next one, it shows distance from the manifold. So it shows that we moved 261 thousandths. So if you pick a random plane throughout your port, you know, it can give you an idea of a measurement, how far into that port you actually are. Honestly, my favorite feature about this machine is after you've created your ports and you've got your tool paths created, it'll show you where your tool has run. And in previous updates, you can hover your tool and it'll show a rendering of it pivoting on these pivot points and as it goes through the port. And with the more recent updates, you actually have a function and it will show you every spot that that tool moves throughout that port. And it's really nice because if you have long ports or ports that are making really sharp turns, if that tool is going to get down and try to rotate where it would actually dig into the opening surface, it'll show you that the tool will be poking through the side of the port. So instead of having to hover back and forth and hope that you catch it with your eye, or running it and just being really careful, you're almost guaranteed that you're not going to hurt nothing with that feature.
Standing in front of our Rottler P69 AHD, it's a cylinder head porting machine. Years ago, when we were all kind of talking about possibly purchasing a machine, because we were porting a lot of cylinder heads by hand, and it was taking just way too much time. You know, literally 8, 10, 12 hours or more for import heads and V8s. We do a lot of imports, a lot of domestic stuff. So we looked at a bunch of different machines, you know, from a lot of different manufacturers. The Rottler basically stood out in front because it's a all-in-one type of machine. So we can hand port it, a cylinder head, get it on the flow bench, make little changes or whatever we want to do, get the head in the machine, actually digitize it in the machine, actually do all the modeling, soft modeling, look at how the port design looks, create all the tool paths, run little tool paths, make changes on the fly if you want, and actually port the head, you know, in the machine. It doesn't have to come in and out, in and out, in and out. You know, stuff that used to take us, like I said, 8, 10, 12, 14 hours. Now with this machine, The CNC cycles are generally 2, 3, maybe 4 hours at the most. So you're definitely saving a lot of time. Yeah, so basically with the Rottler software, after the head has been ported, you obviously put it in the machine and we start the digitizing process. Each of these little slices, as we all call them, the probe will come down and actually digitize each of these little pie slices, as we call them. So it's making a digital copy of what you hand ported. And once these are all digitized, you can actually go through, and if you want to edit the shape of any of these, you physically can just grab any of these lines and points and move them. You know, so if you don't like the way a curve is, or maybe digitizing, you know, the probe hit it just a little funny, or your port wasn't as perfect as you thought it was, you can edit it there. And then you can also run, they have smoothing operations that kind of will help smooth out the port and line everything up a little better for you. And it's all done on the machine. And once you're done with that and you kind of like what you see, then you can actually start creating the tool paths. After it's digitized and you want to, you know, if you have to make any changes, you know, you can make your changes. You can click on any of these points. You can move stuff around. It has smoothing operations to kind of blend the stuff a little better. Sometimes when you hand port, you think you have it perfect, but you don't. So everything can be modeled and modified, and basically you can bring up a solid version and look at it on the port. So it's going to show you exactly what it's going to do before you actually, you know, start cutting ahead. And you create all the tool paths. So basically all these green lines, this is what the cylinder head, the porting tool is going to do, going through the cylinder head, you know, to basically to cut it. And because it's saved and it's all computerized, it's going to repeat the same every single time. We're not all about like making the ports huge. We try to work with them, keep the velocity going and stuff like that. And with the turbo, you can actually CNC port the head, make more horsepower with less boost, which in the long run is going to actually help the engine. So you can have a little more streetable product. But if you do want to, you know, change it up, you do have the room to expand, you know, pick up the horsepower level. We're doing a lot of import stuff. Probably one of the hardest heads we started on and got trained on with the machine was the Subaru EJ series heads. Probably the hardest heads to kind of like jump right into. But we got probably a dozen different programs just for all the Subaru heads alone, all the different castings and horsepower levels and stuff like that. We've got 400 or 500 horsepower street engines up to 1,100 horsepower all-out drag engines. And you know, the sky's the limit. I mean, the awesome thing about the machine is the repeatability. You know, when you hand port, you can get tired, you can get sloppy, you know. Like I said, the hours are just uncountless, but once the program is run, it makes it the same every single time. And if you do want to make a change, you make the change. If you like it, you save it, and it will do it the next time, you know, at the push of a button, basically. The quality that it produces is phenomenal, especially when you consider the price and you look at all the other machines out there. We can do the same with this as everyone else can do with the machines that are 2, 3, 4 times as much money, and probably a lot less technical support. I mean, Rottler's always been awesome with that, and you know, the relationship is probably one of the biggest things on top of the quality of the product and what it produces. Yeah, we quite often get asked, why we picked the Rottler over some of the other machines, and it's just we've had a relationship with Rottler, with the other machines we've bought in, the F68A, serial number 1, outstanding machine, our cylinder hone, the H85, the seat and guide machine, but it's just the price for what you get is just phenomenal.
My name's Brian Harrison. I work for BES Racing Engines. Worked for Tony for about 9 years. Been running these current machines here for about 7. We're here to talk about the Rottler P69. So we use this machine to run numerous of cylinder heads here, BES, and this is one of our heads for a pretty known popular head for Ultra Street. It's a high port, trick flow, small block forward head. We can run this whole particular head in roughly about 3.5 hours in this machine. Intake port, chamber, and exhaust port, and we also run our push rod clearance in this too. That's kind of a nice feature to be able to do. Yeah, this is an intake port. Sometimes we use different length tools because sometimes they chatter, just because tool length, and try to cut more material out. We just try to cut as much as we can with what we can do with our tooling. Get a long tool like that, it's hard, This particular head here, we actually we plug the exhaust bolt holes, then we face mill them in here, but I just do that manually. It's kind of it's not real, just use a fly cutter and just go and shave off the exhaust flange to make it smooth. We go to roughly about the center of the short turn to keep the tool from shanking out, which is usually on the long side would be just a hair below the valve guide typically, kind of where I shoot my line of sight here. I can kind of show you here maybe. This is our tool path here. So yeah, being able to bring this up in the tool path, it helps out a lot to save time from trying to dry run something, make sure the tool's not going to crash. It definitely helps a lot of different scenarios.
Well, Rottler, especially in the, I'm going to say in the cylinder head department, building a CNC machine that was that fast digitizing stuff. Used to be, when I bought that machine, most guys, it took a week to digitize a cylinder head, intake, exhaust, and a chamber. And with Rottler stuff, you can mess around and get it all done in 8 hours easily. My guy's been doing it for quite a while, and he can do it a lot faster than that now. It's very user-friendly. It allows somebody that's not a machinist, somebody that's not trained to be a machinist, to get in there in a couple days with training. You're porting heads. You're ready to go.
So with the P69, we have the Renshaw probe. So we can basically just go in here and click on, bring up a program, make a program, click on here. You can add ports, chambers, you can do patches. But anyway, I brought up a port here, just like an intake port. So basically you would want to start the port on the intake manifold side. We've got to develop planes to digitize to create a port. And you can do all that and roughly do all the digitizing itself and creating tool paths. You can do all within about an hour and a half to 2 hours, according to kind of intake port you have. It saves us a lot of time over doing something like that by hand. To be able to come in and do that for the engine building side of it to get the job done, couldn't even say how much time it saved us, but it's an enormous amount of time. You can digitize a chamber probably an hour, 15 minutes to an hour and a half to get it ready to run also. Say you have a port created, you can go in here and you can just manipulate a port, so you can move the whole port X, Y, or Z. You also have a blend deal for the tool path to make it smoother. We run about a 30 to 32 thousandth step over typically on a finished path. So we try to, like say on our OEM stuff, the guys don't even have to blend them. I digitize a little area on our OEM stuff because it's so consistent, so the guys don't even have to really blend it. So it works out really nice, saves a lot of time. Just blend out one bowl and just digitize that little area where you would do it by hand. And sometimes you got to play with the size to get it to where it don't cut too big or too small, but it works great. So mostly we do all of our digitizing in this machine here, really for no reason other than we just try to keep all of our data in all of our new data in one machine. So you can just take basically a flash drive, and you just hook it in and get your data in a flash drive, then you can just transfer it to the other machine.
The Rottler cylinder head machine definitely made it profitable for us to do one-off cylinder heads and CNC them, and that's a huge help because we do mainly one-off engines, so we don't do a lot of cookie cutter stuff that you can afford to pay somebody a week to digitize ports for you and stuff. This really upped our game.
Welcome back, everybody. Wow, it has been going so well, the Engine Performance Expo. Everybody out there, if you're sharing information, we really appreciate it. We got a good question and answer session. Jaden did such a great job with Warren Johnson. And Kaz, you guys were out there watching. And our setup here, to let you behind the scenes a little bit, like a lot of moving parts making this happen, but we got a lounge where everyone's watching. Like, how cool was it to see the professor and Jaden kind of exchange information, the generations, the knowledge? It was pretty cool from in here. What was it like out there?
Well, it's fascinating. There's so much history there, and he's a legend in the industry. So it's exciting to get to see the past and proven, and there's I guess the difference between the line there from old and new, and what's coming in and what's to come. One thing though that I will say that I find fascinating about Warren is that, you know, so many people get to the point. He's had a successful run, and he's constantly developing and working. He doesn't know the meaning of retirement. You know, he's constantly working, and he programs his own stuff, which is really cool to see. He has a lot of people will just sit back and let technology pass him by. He's not one of those guys. He's every day going into work, getting his hands dirty, and he programs his own machine, and that's really neat to see. You know, a guy that definitely could have somebody else do it, but he has a passion for the industry, obviously.
Well, if you do what you love, you'll never go to work a day in your life. All right, it's time for you guys. If you have any questions, we just put Jaden through the ringer, and Kaz is back. And so if you've got any questions about Axis machining or the subjects we've covered in the past 20 minutes or so, we're going to keep going. Big moments lying ahead. I assure you, you're not going to want to miss, as we've got Ed Pink coming up in a little bit. But as the questions populate, Jaden, what was that like for you, getting an opportunity to exchange information with a living legend?
It was intimidating. The idea of it was at first, but it was an amazing opportunity, and I'm very thankful to be able to have done something like that.
I put you on the spot too.
It was a good thing.
All right, good,
Yeah.
good. That's my. How many times are you going to get that opportunity?
Oh.
Right? And that's why we're doing this. That's why we're doing the whole thing. All right, here we go. Damon, once a port is designed and digitized, can the whole port cut program be scaled larger or smaller for a larger or smaller engine, or higher or lower RPM, to get proper cross-section for the application, rather than starting a new port design?
Simple answer to that is yes. You can scale any section of it, any part of the port, bigger or smaller, by whatever dimension that you want. So, yes.
Oh my goodness. Okay. Here's one. How do we find out which shops in our area have this modern equipment? There's one, and that's what I have been thinking about. It's like, now you can't go backwards. You've learned the right way, that there is a right way, and you need to have something done. Now you have to use the people who only know the right way.
Well, obviously, the quick answer to it is Rottler has invested so much into this industry. I mean, they've been around for 100 years. So their engine machining is very isolated. You know, you hear about part manufacturing, and the problem with it is people hear machine shop, and there is a machine shop that does, you know, anything from the medical industry to whatever, and then there's engine machining, and it's very unique in that it is an industry that has not necessarily a lot of machine shops have not progressed. They're still using some of that antiquated equipment. But Rottler has been the pillar of this industry for progression, and because of that, the easy answer to that is I would suggest calling, you know, Rottler and seeing if there's a person, they know where their equipment is, they know who owns it, they know where they're located. You can call them and contact them, and they can put you in the hands of the right people.
got time for maybe one more question for you folks out there. In the meantime, Bill wants to know, is there a path to watch replays of everything we've seen? Because he's missed Warren Johnson, probably. And the answer is yes, absolutely. What machine shops around me use Rottler is the question mark. I don't want to go calling all of them and asking, like, hey, do you use Rottler? But I guess the answer is to call Rottler, and they know where their machines are.
Right. Yeah, go straight to the source.
Excellent. Well, Jaden, you did a great job. Again, put you on the spot. You came through with flying colors. And what you guys didn't see, you and Warren had like the speed disagreement, which I thought was great. And you hung tough.
I wouldn't call it a disagreement, but there's definitely different applications to do different, I guess, processes.
Excellent. And Kaz, thank you so much. All right, folks, we're going to throw to our next tech chip. So got more information coming at you. And then on the other side, something you're definitely not going to want to miss.